When upsizing a motor's overcurrent protection for high inrush current, the equipment grounding conductor, or EG, must also be increased in size. This requirement is supported by the National Electrical Code, specifically Section 250.122 ATWR. This section states that the equipment grounding conductor for a feeder supplying a motor shall be based on the rating of the overcurrent device protecting the circuit. Furthermore, it specifies that where the feeder overcurrent device is rated in excess of 1000 amps, the equipment grounding conductor shall be not less than 1/2 the size of the circuit conductors. This code provision exists to ensure that the EGC can safely handle the maximum fault current that the overcurrent device allows to flow. The EGC provides a low impedance path for fault current to return to the source, facilitating the rapid clearing of a ground fault and minimizing the risk of electrical shock or fire. Sizing the EGC appropriately is crucial for maintaining a safe and effective electrical system. Consider an example involving a 208-volt, 2-horsepower, single-phase motor. The minimum circuit ampacity for this motor, based on nameplate current and applicable tables, might be calculated to be 16.5 amps. In this scenario, you might initially select 12 AWG conductors for the motor circuit. However, the motor may not start and run reliably with a 20 amp overcurrent device due to high inrush current during startup. To address this, you might consider increasing the overcurrent protection to a 30 amp inverse time circuit breaker. The question then arises, does the EGC also need to be increased to match the 30 amp breaker? According to NEC section 250.122 ATWO, the answer is yes. The EGC must be sized based on the rating of the overcurrent device protecting the circuit. This is because the EGC provides a path for fault current to flow back to the source, and it must be able to handle the maximum amount of current that the overcurrent device can allow to flow. When the overcurrent device rating is increased, the maximum amount of current that can flow through the circuit is increased. This means that the EGC must also be increased in size to ensure that it can handle the increased current. In the example provided, the overcurrent device rating was increased from 20 amps to 30 amps. According to NEC 250.122 ATWR, the EGC must be sized according to Table 250.122. This table provides minimum sizes for equipment grounding conductors based on the rating or setting of the overcurrent protective device in the circuit ahead of the equipment. Since the circuit conductors are 12 AWG and the overcurrent device is now 30 amps, the EGC must be at least 10 AWG copper, if using copper conductors. The NEC provides specific tables, such as Table 250.122, to guide the selection of appropriate EGC sizes based on the overcurrent device rating. These tables consider the ampacity of the conductors and the need to provide a low impedance ground fault path. In addition to NEC section 250.122 ATWR, other sections of the NEC may also be relevant when sizing EGC for motor circuits. These sections may address specific requirements for different types of motors, wiring methods, or applications. Consulting the NEC and other relevant standards is essential to ensure that the EGC is properly sized and installed. Firstly, determine the motor's full load current from the motor nameplate. Secondly, calculate the minimum circuit ampacity by multiplying the full load current by a factor specified in the NEC, typically 1.25 for continuous duty motors. Thirdly, select the appropriate size conductors based on the calculated ampacity and the ampacity ratings in NEC Table 310.16, considering conductor insulation type and termination temperature ratings. Fourthly, choose an overcurrent device that is capable of handling the motor's starting current without nuisance tripping, while still providing protection against overloads and short circuits. NEC Section 430 provides guidance on selecting motor overcurrent protection. Fifthly, size the equipment grounding conductor based on the overcurrent device rating as per NEC 250.122 and Table 250.122. Sixthly, install the EGC in accordance with NEC requirements, ensuring it is properly connected to the motor frame, the disconnecting means, and the grounding electrode system. Finally, verify the continuity and integrity of the grounding system using appropriate testing methods. To ensure you are making the correct decision in increasing the equipment grounding conductor, you can firstly consult with a qualified electrical engineer or electrician. Secondly, conduct a thorough review of the electrical system design and applicable codes. Thirdly, perform calculations to verify the adequacy of the selected EGC size. Fourthly, document all decisions and calculations for future reference. Remember that the NEC is a comprehensive document, and it is essential to consult the latest edition and all applicable sections when designing and installing electrical systems. Local codes and regulations may also have additional requirements that must be followed. Proper sizing of equipment grounding conductors is crucial for electrical safety and the reliable operation of motor circuits. By following the NEC and other relevant standards, you can ensure that the EGC provides a safe and effective path for fault current, protecting personnel and equipment from electrical hazards.